Hi, in this video, I will show you how to make a simple sine wave oscillator in pure data. Let's begin. Okay, so let's start by making a new patch and let's make a cycle object. Okay, so that's cycle with a tilde as space 440, and that sets the frequency in hertz. So that's A4, right? And then let's do a DAC. Let's connect this. And I'm not getting any sound, and that's because I have the DSP turned off. So it's on the lower right corner. There I can turn it on, but I would recommend you to lower your volume first. Okay, so let's lower the volume. Let's turn it on, and then we can hear it, right? There it is. Okay, let me turn it off because that gets annoying really fast. Okay, now let's make a number box and connect it to the first inlet of the cycle. This sets the frequency in hertz, and so this will replace that 440 that we just had, right? So this is frequency in hertz. That's the first inlet of cycle, and that controls the frequency. Okay, so let's turn it on back again. Let's move this. Okay, awesome, right? But how about amplitude, right? Because we haven't touched amplitude, and how do I change the volume for this oscillator? Because you wouldn't want to turn on and off the DSP every time you don't want to hear the oscillator, right? So we need a volume control specific for this oscillator, right? So I'm going to delete these cables, and we're going to make a multiplication sign, and let's connect it right there, right? Let's turn on the DSP, and so we don't hear anything. That's because we're basically multiplying by 0 right now, right? And the output of a cycle is an oscillation. This is the output, right? Let me put it here. Output is an oscillation that goes between -1 to 1, right? And so you multiply both ends, right? -1 times 0, 0. You multiply 1 times 0, 0. That's why we get nothing. We get 0, right? But if we multiply this by 0.5, now the output of this multiplication, it's an oscillation now between -1 times 0.5, well, 0.5, and 1 times 0.5, 0.5. There you go. And if you multiply this by 1, you get the full amplitude of the sine wave, right? There you go. Cool. So this is where we check the oscilloscope. This is scope with a tilde. And we go into the inspector window for that oscilloscope, and we change the the samples per point to 2, buffer size to 256, and set a delay of 100 milliseconds. This is for you to, I'm going to change the background color as well, so it's a little bit clearer. This one too, and let's have this like a green. There we go. So this is the waveform, right? This is the output of the oscillator. It goes again from -1 to 1, and after the multiplication, we get 0, right? That's 0. That means nothing, right? And again, if we multiply this by 0.5, ta-da, it's going from -0.5 to 0.5. That's approximately -6 decibels. Cool. But let's program a slider or fader or whatever you want to call it that controls the amplitude of this oscillator, right? So let's make an hslider. Here it is, hslider, horizontal slider. And we change its value from 0 to 1. Okay, this is amplitude control from 0 to 1. It's really important that it needs to be between 0 and 1. And I'm going to connect a number box after this, okay? And so we can see that this goes from 0 to 1, right? And all the decimal points in between. Cool. Now I can connect this over here and move this. We can have full amplitude. But if I move it too fast, you might notice that we get some clicks. That's because the sample rate for data is 1 milliseconds, while the sample rate for audio, it's 44.1 kilohertz. That's a ton of difference, right? So 1 millisecond would be, I don't know, in hertz would be 1000 hertz, right? So it's not comparable. So we need more points, we need more resolution, right? So in order to do that, we need to convert from data to audio. And you see here these striped cables, these are audio cables. And the orange dots those are audio inlets and audio outlets. And the blue ones are data outlets and inlets. So to change this from data to audio, we need to use pack F20, and then we need to use line. The combination of these two objects will provide a smooth ramp between points, between numbers. So that way, we don't get clicks. And what's going on here is basically, right, so let's do it something like this. So there I have 0.21. So what pack does, it's packing F, it's packing the first number, and it's adding or appending a 20 to that list. So we are getting 0.2120. Line reads this as go to 0.21 in 20 milliseconds, right? Okay, that's what line does. Or if I send a new number, it will go to 0.63 in 20 milliseconds, right? So for example, if I go from 0 to 1 and then back to 0 really fast, we can hear that that's fast, right? But that's 20 milliseconds. If I do 2 seconds, 2000 milliseconds, and I go really fast, we can hear that it takes 2 seconds to get to 1. And then it goes back to 0. So it takes more time to go to that particular number, right? So it creates like a ramp. We can actually see it in action here if we connect the line to the scope. You can see that it takes time to go to 1. If I do 20, it doesn't take that much time, okay? So that's why we're using that. And well, that's basically how you program a simple oscillator in Pure Data and Max with the cycle and the multiplication to change amplitude. That's really important. This changes amplitude. This is an attenuator or amplifier, depending on the numbers you send. And it's also called a VCA for controlling amplitude. In more common terms, that's volume. So again, remember the multiplication sign with the tilde. Well, that's it. I hope you learned something, and I will see you on the next one. Peace.